All right, CNT120, Chapter 1. We're now working on the section on network models. So network models, one of the first terms they introduced to us is topology. Topology is a term that describes how the parts of my network basically come together, how all the parts of the whole work together. So there's two types of topologies that we have, physical and logical. Physical is kind of what its name implies. How are all these devices connected together to make my network in our case? How are they all connected together? So this is really applying to the hardware, computers, devices, cables, that sort of thing to pull my network together. And if I look here, next slide, I have an example of physical topology showing my computers connected together to devices like switches, out to a router, out to the internet, etc. How are my devices physically connected together? We're eventually going to talk about things like bus ring star topologies, so we'll be revisiting some of this idea a little bit later in the chapter. The other terminology is logical topology. How is my software controlling how my data moves through my network? So now we're talking about things like peer-to-peer and client server. How is the flow of data through my network occurring? How is it flowing? So if I look here, I think this one here, I think I have one here logically. This one you're seeing, we're not actually seeing things like switches and so forth here. It's just like, this does not concern itself with that. So it's showing things like IP addresses and how data would be moving through this network. What kind of networks, what kind of subnets, that sort of thing is my network. All right, so with this, we now need to introduce a couple other terms. We need to introduce some operating systems as well as the peer-to-peer client server thing. So let's talk network operating system real quick. We're familiar with operating system. Operating system is the software on my computer that makes it function and do my things I need it to do, like browse the internet, be able to download files, be able to email, that sort of thing. That's my operating system. Well, for networking, we have what's called a network operating system. This is the software that's typically on a server that is going to provide my network server functions, if you will. Things like DNS, DHCP, file and printer sharing, resolving names to addresses, handing out IP addresses to devices on the network, allowing me to share files or move files between the server and me, being able to print to a printer in my network somewhere. This is controlled by my server operating system, or a lot of times you'll hear it called a network operating system. Well, let's break this out a little further. Let's remember desktop operating system. Well, this is the desktop operating system. This is what's on our computer that I'm using right now. I'm using my Windows laptop, if you will. You might be using an Apple laptop. You might be using a Chromebook. That is the operating system making my hardware function and do the tasks I want it to do. And if I take a look at the usage share here, here's the usage share of operating systems. Wikipedia, they actually update this for you. So this is kind of like a real quick, I can scan to get a quick idea. Let me scroll down here to, I don't want web clients, I want like desktop laptop. Here we go. If I look at the desktop laptop breakdown, it is no surprise that Windows for my desktop laptop operating system, almost 75% of the market share is Windows. And Mac is in there behind with 15%, and all the other ones are kind of taking up the rest. That is really not a surprise at all. Most of our desktop, laptop things are running Windows or some variation of Windows. But let's remember real quickly, I threw kind of a quick timeline here of the different Windows operating systems through the days: 3.0, NT, 95, 98, ME, XP, Vista 7, 8, 10, 11, etc. These are the Windows operating systems through time. There are others out there. Here's Apple operating systems through time. A lot of these have used big cat names for quite a long time, and then moved on to kind of like parts of the country, parts of the world, if you will, almost like national park kind of identity. There's a Apple operating system through the time and kind of their releases and so forth. But we also have Linux desktop operating system as well. And there's a lot of different flavors of this because Linux can be, I can download the core and put my own wrapper, my own package around it. So there's a lot of variations out here, but I threw out here some of the kind of the big ones that you run into. These are a lot of the big ones that you run into. And then here is desktop Linux that can be, there's a free counterpart Fedora, and then you can actually pay for Red Hat Enterprise Linux, what actually gives you some technical support, some support for their product. And here's kind of the breakdown of the Fedora and Red Hat connection, if you will. Well, that's my desktop OS. Now when I move into the server side, remember, in my network, a server is there to do some functions like handout addressing, be able to hand out files or save files, be able to hand out IP addressing, be able to resolve names to IP addresses, a bunch of network functions that are needed in many, many networks. And the thing that's going to do that is a server loaded with a server operating system. Okay, and that is, let me show you real quickly here, Windows Server, Linux Server, Apple Server, and if I go back in time a little bit, Novell Server. These are the big server OSs that you encounter. Now, let me just do this real quick. When I move into the server world, let's go back to our market share, usage share of operating systems. Okay, I'll go back here to that. Here's my desktop, laptop computers. I'm going to keep going. Computer games, mobile, OS, okay, I'm going to keep going. Tablets, keep going. Public servers on the internet. So these are ones like web servers, mail servers, DNS servers that are connected out to the internet. If I look at the server operating system on these devices, what I find is a good portion of them are Linux, Unix, and a small portion is Windows. It kind of flip-flops when I jump into the server world. When I get to the server world, you tend to find more Linux than you do Windows. And this is just one example. This is just one example. On other parts of the network, you might have more Windows servers. But your two big players here are Windows and Linux. Windows and Linux when you get to the server world. There's the two big players. Networking people, down the road, we have you take a Windows server class and also a Linux server class, if you will. Just kind of giving you a little heads up down the road. So you'll get some experience working with those. Well, let's take a look real quickly over time. Here's kind of the Windows Server releases starting back in NT days, the whole way up to Windows Server 2022. Here's some Linux Server through the years, starting back Red Hat Enterprise Linux 2.1. You could do server functions with older Linux variations. I'm just giving you one example here. Here's all the releases up to Red Hat Enterprise Linux Server 9. And then again, Apple had, they have their own server utility as well. Again, there's a bunch of versions of theirs up to, again, Server 5.12. Okay. One group you may not have heard of is Novell. Novell servers were kind of the first. They were really one of the first ones on the scene to do this file and printer sharing thing back in the 80s, long before Windows did. Their popularity has waned. Many places that were running Novell have migrated over to Windows or Linux for that matter. But Novell, here is the NetWare server that they had. They bought a Linux core, if you will, and turned it into Open Enterprise Server, and they've continued support of that over the years. But again, their market share is a lot smaller than Windows or Linux, if you will. But just kind of keep them in the back of your mind that they were one of the early players in server OS, and they're still out there, but they have now a Linux core, if you will. Okay, so now that brings us to peer-to-peer and client-server. Well, peer-to-peer model is when literally all the computers act as both the, I hate to use the word client and server, but they basically act on their own. Each operating system is responsible for what people have access to. So there is no centralized like server control. Each client is, each device, each computer is saying, okay, here's the things I'll share with you, the rest I won't share with you. So this becomes a little workgroup environment where the devices are literally sharing with each other. I'm literally sharing a folder on my laptop with, somebody sharing a folder on their desktop, and we can move files between them. This works in a small environment with a couple computers. I like to pick on, our church for the longest time had a peer-to-peer network, the secretary and the pastor and the youth leader and the children's leader all shared files between them, and it worked fine for quite a long time. We have migrated away from that, but for a long time that's how they moved, article around from the children's department up to the secretary to put in the newsletter, to mail it out, and that sort of thing. This works well in a small environment, a couple computers, but each device literally has to control what gets shared, what does not get shared. So if I look at a peer-to-peer model, it is simple to configure. It does not take much. I don't need a special operating system. Most operating systems have the functionality built in. All I need to do is turn it on. And it is really not expensive to set up or maintain. There is really no extra thing I need to do. The downside of this is it is really not flexible or scalable. If I have to go around and maintain 10 computers and what gets shared and what does not, that's a lot of work. If I try to do it with more, it's like, it becomes even more of a headache. It is not really that secure. You can put a password on the folder, but that's about it. You might be able to limit who has access to it, but that's about it. There is no central admin for this. There's no central point that I have control over all this. There's no central point that I'm backing it all up. I'll use my church example again. If the secretary's computer fails, anything that's on there that was shared is done. That's it. It's gone. So this is really not practical for any large installations. It is fine for maybe your house, or like I said, a church with just a couple computers, a couple of people that are sharing, but is not practical for a large environment. Which brings us to the client server. The client server now, you literally have a server that is managing the network, who has access and who has access to what. Typically, in a client server environment, it's usually a Windows server that's maintaining all of that through Active Directory. And Active Directory, I think I have a snapshot here on the next page. Right there. Here's a sample of Active Directory. Active Directory literally has people, almost like a directory of people and devices, and you can put permissions on the people, what they have access to, and the devices, what they have access to. So now we have almost like a traffic cop in there saying, yes, you can, no, you can't. Yes, you can log in, no, you can't log in. Yes, you can access this folder, no, you cannot access this folder. And that is all controlled typically in your Active Directory. And that whole area is called a Windows domain. All those things that are being managed or monitored. Now, typically users on this network have a kind of a global username and ID, which allows them to, I'm going to pick on our network for a second. If Mr. Brown teaches in Harrisburg in the morning, I could log into the network and get access to my files and folders. I could log out. I could drive to Lancaster and teach in Lancaster in the evening. I should be able to log in down there and have access to my same files and folders. Which I am able to do. That is handled because of the server has this global account for Doug Brown to have access to all of that stuff. So with a client server, I now have the server acting as my traffic cop of, yes, you can have access, no, you can't. Yes, you have access to this folder, no, you don't have access to that folder. And that's what I'm showing my picture here to. The server is now in the role of playing that traffic cop. What do you have access to? What do you don't? So it's going to manage all of these things, all those examples I kept throwing at you. So some examples are my Windows server that we were mentioning before, my Linux server, there is Mac OS X server, all those will get the job done. I might need to install some extra memory and processing and storage capability for my server, yep. And I might even need to install some extra hard drives and put a RAID array in. RAID array, a redundant array of independent disks. Those disks are in there to back each other up. In case one fails, there's copies on the other disks that I won't lose data. So if I look at some advantages and disadvantages, I use the example of a credential assigned from one place. Yes, all my user accounts are managed from one place. I can have shared resources centrally controlled from that one place. It is scalable for a large company. You can handle hundreds to thousands of users and devices. This is much more secure, yes. And I do have that central admin. I do have that central admin from that server locale, if you will. Downside is it is not simple to configure and maintain. You do need somebody trained to do this. You're not going to have, Joe Schmo coming off the street to do this. You need somebody trained to do this. It is more expensive to set up and maintain. That server operating system is expensive, and I do need that server operating system. I'm not going to do this just with my, my Windows XP laptop. I'm not going to do that. It does not have the capability. So there, real quickly, is our peer-to-peer client server.